Right. Our next program is program number 9. Develop a program to implement random forest classifier model. Right. Right. Our next program is program number 9. Develop a program to implement random forest classifier model and analyze the model using confusion matrix. So knowing about how is random forest classifier working, we'll basically develop a program in Python, and later we will be basically taking a CSV file, apply a random forest classifier model, and then we need to analyze the model using the confusion matrix. So this is our program. So the first is to import the libraries required, and then I am reading a CSV file. So the CSV file is basically user data.csv. So just going back to your user data CSV, this is your user underscore data CSV file. Right. So it consists of user ID, gender, age, estimated salary, and purchased. So as usual, you can observe here that the purchased is consisting of the values either 0 or 1. Right. So this is an output, and user ID, gender, age, estimated salary are basically your inputs. Right. Going back to the program. So this is about your user data.csv, and the same we have read the CSV file, and then we are printing the data set. So data set is equal to pd.read underscore CSV of the CSV file is user data.csv, and then we are printing your data set. So this is the output of this file. That is, as we have seen earlier, user ID, gender, age, and estimated salary are the input variables, and purchased, you can see here clearly, the purchased has the value 0 or 1. So there are totally 400 rows and 5 columns. These are the 5 columns, 1, 2, 3, 4, 5. And in such way, there are 0 to 399 rows. So the total dimension of this particular user data.csv is 400 cross 5. Now, as we are using your ilog to retrieve the specific rows. So when I am writing dataset.ilog, dataset is obviously assigned to user data.csv. And now I am retrieving that x is equal to dataset.ilog, and I am indexing using the index. I am basically retrieving the data 2, 3. So this specific rows, you can see here, when I print x, you will be getting 19, 19,000, 35, 20,000, and so on. So what are retrieved basically here? 2 and 3, that is age as well as your estimated salary. These two columns are retrieved by this particular statement. Similarly, I am storing the fourth one, that is, which is your output variable, purchased variable, in y location, that is y variable. So x is equal to, I am storing age as well as estimated salary, and y is equal to the output variable, which is purchased. So that is done by these two statements, and I am printing your x, and then I'm printing y as well. So the y values, as usual, it will be your 0s and 1. It is retrieved here. These are the rows, these are the values respectively. Right. Now there is a purpose of this one, which we'll be seeing later. Right. Now from sklearn.model underscore selection, I am importing training underscore test underscore split. So what I basically do here is x underscore train, x underscore test, train, and y underscore test. These 4 are the normal variables. And now I am using your train underscore test underscore split to split this particular data set. So what I am splitting x, y, test size is equal to 0.25 and random state is equal to any number. Usually in order to retrieve the data consistently, we use random state. Test size is equal to 0.25. This clearly states that the training data is 75% and the testing data is 25%. Right? And respectively, x comma y data is split. What is x comma y actually? X is having 2, 3, that is age as well as estimated salary of all the 400 rows, and y is consisting the data of the purchase for all the 400 rows. So that is your x comma y. So when I am giving test size is equal to 0.25, that means 75% of the rows, 75% of the rows actually considered as your training data, and remaining 25% is considered as the testing data. So that is what is done in these two statements. Right? Now, After this, I'm using one more statement, sklearn.preprocessing import standard scalar. So this standard scalar, and just observe here, there is one variable where I am initializing the standard scalar method. Then I am using st underscore x dot fit underscore transform of x underscore train as well as transform of x underscore test. So you know here x underscore train and x underscore test, y underscore train and y underscore test. So this x, 75% of the x is stored as x underscore train and remaining 25% of the data sits in x underscore test. Similarly, this y, 75% of the y actually is assigned to y underscore train and the remaining 25% of the test data, that is y, is basically stands as a test data. So we have x underscore train, x underscore test, y underscore train and y underscore test with us because of this particular function called train underscore test underscore split. Now I am basically using, just if you just observe here, the method used here is fit underscore transform. Now what are you basically transforming here? I'm trying to transform x underscore train, which has been initial, that is the 75% of the x values, even x underscore test, that is 25% of the x values. Now why is this required is, now we can observe here that I'm using age as well as estimated salary and I need to predict the purchase. So the ultimate, what does machine learning algorithm do is it is going to predict for a given age and for given estimated salary whether the purchase is 0 or 1. So we usually have user ID which just stands as an ID here, gender which is male or female, but we are ignoring these two and we are giving importance to age as well as estimated salary. So age as well as estimated salary are basically used to right, age as well as estimated salary are playing a major role in order to identify whether an item is purchased or not. So age 19 and the salary is 19,000, they are not purchasing. This is what the meaning of this particular data set is. The age 35, 20,000, they are not actual purchasing. Now you can see here 46 is the age, 41,000 is the estimated salary, and they're being basically going to purchase the item. So age as well as estimated salary, out of all these 4 columns, we are choosing only age as well as estimated salary to predict the purchase. That means I am giving these 2 parameters are basically chosen. Now, when I am giving age, you can see the maximum to maximum range of the age will be 80 to 90, not more than that one, right? But when you see estimated salary, it is something in thousands, right? So there is no actually comparison of this data to this particular data. Why? Because hardly you can't even take 3 numbers in the age, right? Age can be maximum 50, 60, 70, 80, 90 also, but more than 100 and all, you basically don't take your age. So there is no comparison between the age, which is hardly having 2 digits, and an estimated salary, which usually has 5. Commonly it has 5 and more than 5 digits also. So here we basically need a standard scalar to scale the age as well as your estimated salary into common common form. So for that reason, basically we will use the method called as your standard scalar, right? So what basically why is this? For example, consider there is another parameter which is also in the same range, you don't need to do. But when I am giving the algorithm, machine learning algorithm, to predict one output with this particular age as well as estimated salary, right? So there needs to be a common normalization of the age value, because age is having 2 digits and your estimated salary is having 5 digits. So your machine learning algorithm otherwise cannot understand, or it cannot predict the output. So that is the reason a standard scalar is required here. Now, next, so once we scale, that is we scale the values, right? You can just basically check here. I'll be running the code once. Right. So this is the output. Then once again, we will rerun the code. So this is the output. I have printed only X here. So you'll be getting basically 2, 3, which is age and estimated salary values. And then print Y. So Y is obviously the purchased, either 0 or 1. And then I'm going to divide the data into testing data and training data. So training is 75% and test data is 25% here. Then I basically standardize the data. So for example, if I print x_train here, right, you can see the values are being standardized here. There are x_training data is having two values. One is age as well as the salary, but they both are now normalized into common factors for further supplying to the model. Now, even you can print your once x_train is done, we'll insert one more cell, and this time we will even give the values of, we'll print the value of x_test as well. Right, you can see. So both the values will be now in the standard scale. Right. So this entire thing is like your data pre-processing only. We didn't even still start the actual model. Now here comes the actual model. So we are going to use your sklearn package and we are importing directly your random forest classifier. So our program is develop a program to implement random forest classifier model and analyze using confusion matrix. So here we are basically applying the random forest classifier. And these are the major two parameters which we have been, out of many parameters, we have chosen two parameters under random forest classifier method. One is n_estimators and the other one is criteria. So knowing about your random forest classifier, it basically combination of your decision tree. So it follows the ensembling technique. And it is like learning about your decision tree. Then we have actually learned about random forest classifier, where forest is a combination of many trees. Now, so we will be creating many number of decision trees, and each decision tree's output, whatever the decision tree is predicting, you will be either averaging or you will be considering the majority voting, and you will be taking the output from that one. So this n_estimators inside this function stands for number of trees. That is, we basically consider it as the number of trees. And the next one is criteria. So the criteria stands many other things like the Gini, and you are having entropy. And if it is regression inside your random forest classifier, random forest regressor, then you basically have your mean as well. That is your MSC as well as NAE also. So this is what your random forest classifier in brief, that is in brief. So we are basically applying the method, and these two are the major parameters which will affect random forest classifier, because if I don't know how many decision trees to construct in the random forest classifier, then you can't actually predict the output, or you can't even continue with your model also. So n_estimators basically stands with the number of trees you are choosing. And this is the splitting of the data, basically to split the measure of your splitting. So the criteria we have chosen, as we have studied in the example problem of random forest classifier, the criteria we have given is entropy. You can either use your Gini as well here, right? So now we are fitting the data. The method we are using, like all the other models, we will be using basically the fit method. So what are we fitting? x_train and y_train. These two are the parameters. So I am choosing random forest classifier. I am applying the function, and then I am fitting the data for the data with x_ and y_train. So the model will now learn the data with basically, already you have basically split the data into training as well as testing data. As we have seen here, we have basically split the data here, right? Now I am training the model, that is your random forest classifier, with this particular x_train and y_train. So once you run this cell, you can see the output. Right, this is whatever we have basically given. This is the output of this particular, these three statements. Now we will write classifier.predict_x_test. So what is basically happening here? I'm actually training the model with x_train and y_train. So what was our training? How much percentage of the data we have taken? This particular thing is actually 75% of the data is basically given as your for prediction, right? That is for, it is basically given for training the model, right? So this is for your training the model. And in the data, we have x. X is a combination of your age as well as what is the next one which we have seen? Salary. So these two are your x, and your y is basically your purchase. So the item is purchased or not is basically your, right, purchased or not is basically your y. So what we have done, out of many rows, whatever is available, 75% of the data, with this particular 75% of the data, we have trained the model with x comma y. So you can see here x underscore train as well as y underscore train with this particular 75% of the data. So now that is with this age and with this salary, the purchase output is 0. With so and so age and so salary, the purchase is equal to 1. With this 75% of the data, your model learns. Which model now? Random forest classifier basically learns with that one. Now after that, what we are doing, already your x underscore test also was there. The remaining 25% of the data which we basically use is for your testing only. So there is x underscore test as well as y underscore test also. So once we train the model with 75% of the data, how you basically train? With your x underscore train and y underscore train, right? And then now with this remaining 25% of the data, I'm predicting the output. That is for this x underscore test, what is your model basically giving the data? That is what we have written here, classifier.predict of x underscore test, right? Now we are printing y underscore predict. You can see that we got the output here, which is in terms of your zeros and ones. So now there is the actual output also. What is your actual output? It is your y underscore test. Y underscore test is basically our actual output. Now what is your prediction? Prediction is for this particular x underscore test, you are predicting the value. How are you predicting? With this classifier. What is our classifier? Random forest classifier. So now you will be printing your y underscore predict. Now it has given zeros and ones. Obviously, it will be giving your zeros and ones. Now what is left out? The comparison is left out. That means already you have the exact data. That is the actual y underscore test is there with you. And whatever your model has predicted is also there with you. Now you can't keep comparing your values. All the 400 cross 5 values, you basically can't keep comparing, right? So what we basically do, now we analyze that model using confusion matrix. So this is your confusion matrix, right? So what we'll be doing here now, as I said you, y underscore predict is whatever our model has predicted. Y underscore test is from your exact CSV file, that remaining 25% of your y. So these both I am basically giving to your confusion matrix and I am printing the confusion matrix. So confusion matrix basically gives you these values. These are basically your true values, true false values, false true values, that you basically call it as true positive, false positive, true negative, false negative, right? So in that way, so just for analyzing, this is what this confusion matrix has given you. So you will be basically considering the diagonal elements. So 65 plus 27. So usually the diagonal elements are correct. That is, if my model is predicting 0 and the actual output is also 0. My model is predicting 1 and the actual output also 1, right? So this is correct values. But there are other cases, like my model is giving 0 and my model is giving 0 and the actual output may be 1, or there may be 1 and 0. So these two values are usually part of the diagonal elements here. That means out of these values, total how many, what is the prediction? 65 plus 3 plus 5 plus 27, right? This is our total predictions, out of which 65 plus 27 are correct. That is, the diagonal elements are correct. And there are 8 mismatches here. 5 plus 3 is your mismatches. So the accuracy will be 65 plus 27 divided by 65 plus this value, the complete value. Obviously, the total number of values. So whatever the values are there, so it basically predicts. Now, this accuracy score is given by using y underscore test and y underscore. This is for your analysis, right? Analysis, right? So the accuracy is 0.92. Now, if you divide 65 plus 27 divided by, if you do 65 plus 3 plus 5 plus 27, the accuracy is directly calculated and the accuracy value is 92%, which is very good score for our user underscore data.